Okay, 5.2, we're going to verify trig identities. You've been doing that. You've had all the skills the last 2 days. Your assignment was to get you used to using your trig identities. 1 over sine is cosecant. And that. The ones that you guys probably, hopefully, are starting to really come... Remember, is sine squared plus cosine squared is 1. And 1 plus tangent squared is secant squared. How can we remember that it's tangent and secant?
You don't.
What's in the denominator of both tangent and secant? Cosine. And 1 plus cotangent squared is cosecant squared.
Because of denominator
And sine is in both denominators. Okay? So those are the 3 that we should remember. Anytime you see squareds, you should be thinking Pythagorean, all that kind of stuff. So there are some things we have to remember. I've yelled at several people the last few days to work which direction, Natalie?
Sideways.
Down. Okay. When you work these problems, you will have a format you have to do, just like we did Gauss-Jordan. You will need to work down. Your equal signs will need to line up. And we will put our mathematical equivalent to a period at the end as the little rectangles. Some books you'll see triangles. If you look at your textbook and you haven't noticed, but every single example has a little box at the end. Every single example in your textbook has a box because it is telling you that they are done. They're done with the problem and there's no more.
Can we put a star instead of a square?
No. You can use a triangle or you can use a little rectangle. I don't care, but you cannot use any other shape. Okay, so your directions are going to say things like verify the trig identity or make the left look like the right or the right look like the left. I will tell you, you have to line things up. So some people switch it so the side they're going to work on is always on the right so it can expand out and they can line up those equal signs. I don't care what you do, you just got to figure it out. And that comes from practice. So I have secant of theta minus 1 over secant squared theta equals sine of theta. Sine squared of theta. I personally leave myself some space so I can expand on this side. You usually try to work on the more complicated side unless it tells you. Yes?
Actually, okay, so I was going to ask you this.
Mm-hmm.
I made the whole, from the chart and then I wrote it all out. And when I watched the video the other day, you wrote, cosine 60 equals a half on cofunction.
Mm-hmm.
What do you mean by that?
What cofunctions are if the two angles are complementary, meaning they add up to 90 degrees, then the cofunctions are equal. So if I have the cosine of 30, which is square root of 3 over 2, that means that is also equal to the sine of 60, which it is. Because 30 and 60 equal 90, and sine and cosine are cofunctions.
Okay. Because I saw you wrote that, on the side of them, and I was...
Yeah, there was a whole example that went with that. Yes?
Okay, for that question, doesn't the secant cancel out?
Okay, no.
No?
So let's focus back on here now. Okay, so which side is the more complicated side?
The
The
left.
left. It has more pieces. So in our brains, is it easier to go from something large down to something small?
Yeah.
Yes. Now, we can go from something small and multiply by conjugates and add things in, but it's hard to think about. So we're always trying to do that. Now, thank you for trying to do that so wrong. Thank you. There is a minus up here. So there is an imaginary what around this numerator? Parenthesis. And it is a quantity. So unless you can reduce the whole thing, you may not pick it apart. Now, you could factor it, because is this the difference of squares? Yeah? I could factor it, but I also could think, oh, I see a squared. So, well, that Pythagorean identity is right here. Could I make this look like this.
Add the 1 over.
I wouldn't add the 1 over. I would subtract 1,
Side.
and then secant squared minus 1 equals what?
Tangent.
Tangent squared. There are many ways to do these problems. When you come with questions, I will ask you the steps that you took, or I'll say, hey, bring your paper up here and we'll go through it. Because I don't want you to always be, Mrs. Mick, what's the first step? Because if you can't take a first step without me, are you ever going to be able to do them?
No.
No. And I will always try to work, even if it's a horrible way to do the problem, I will always try to stick with the way you're doing it, because how you see it and understand it is going to be the best way to do it. Okay? So we've decided that secant squared minus 1 is tangent squared. So I write tangent squared. I don't write the theta or the u or the x. I write it in the beginning and I write it at the end. If you want to write it every single step, that's fine, but it has to be at the beginning and it has to be at the end. Okay? And then I have secant squared. I bring my equals and I line it up. I'm not changing signs, so I don't rewrite it. If you want to rewrite it, go for it. But it's just implied if you don't change it, it just keeps coming down.
So the next one could be, wait,
Okay, well, let's think about this. We're trying to get sine, correct?
Yes,
So we should probably turn these things into like sines and cosines.
we should.
Should. Okay, so tangent is whatever what.
Sine over cosine.
So I have sine squared over cosine squared. And when I'm dividing by secant, I can also multiply by 1 over secant, yes? But what is secant? 1 over, I'll just do it.
1 over cosine.
I'm not going to skip. Okay, so I've got that. Well, 1 over secant squared equals what?
Cosine squared.
Cosine squared. So I change it. You notice I'm not writing any work. I'm writing the result. The work, if you've got to do work, has to go somewhere else. It does not go in your problem. Again, like we did with Gauss-Jordan. So from here, what happens? What math occurs?
You multiply them and the cosines reduce.
What? Well, we already reciprocated it here. So these cosines reduce. Don't cross them out. Leave them there. When I reduce, what am I left with?
Sine squared.
Sine squared. Is that what I needed?
Yeah.
So it's sine squared theta, and now you bring all this down and you get sine squared theta, and you put a box. So you've said, I'm done, prove me wrong if you don't like it.
Zero.
The left is exactly like the right. Some mistakes I get is people go, oh, this is sine squared, so they just put sine squared on the right and stop. Your last step, the left, has to be exactly the right. Should be the easiest step.
We've done this already, correct?
Yes, we've done short ones before.
Okay.
We have?
Yes, like at the beginning of chapter 4, like first time we introduced you to the, I think it was like 4-3 or so, 4-4. We've done short ones. We are going to be going more complex.
Okay, I briefly remember that now.
Okay, if going down bothers you, you can't handle it, you keep trying to go sideways, fold your paper in half, would be my, because then you could do one on the left, one on the right, or whatever. Okay, so now I have,
For the, okay, when you, because I'm looking at it, and for the beginning, when you, it was like secant squared theta minus 1, did you just take the Pythagorean identity?
Yep, I just used the Pythagorean identity. Now, we're not justifying, I did not make you justify anything, and I didn't say by Pythagorean identity. I didn't make you do that, right? If you guys go with one identity, one step, or reciprocal, like if you could use the reciprocal identity like 6 times in one step, you can use it. But you stick with one thing, one step, I won't make you justify it. Okay, if you want to justify it, that's up to you. But yes, I just went to my Pythagorean identity and used it to come to here.
Okay, because I was just really confused because I was like, we went from that to tangent squared. I was
Right.
Really confused.
But before we did that, we went up and discussed how we could rearrange this.
Okay.
Okay, so now I have 2 secant squared of alpha equals 1 over 1 minus sine of alpha plus 1 over 1 plus sine of alpha. I feel like can you see that pen okay? Everyone can back there see
I
that.
can like having a hard time remembering.
Okay, that's what I'm at.
I mean, it's a little bit light.
Does that help, or do I need to go to a different pen?
It helps a little bit.
Okay, I'll switch to a different pen. This is just a really fine pen. Usually green isn't a problem, but that's really fine. Okay, I'm going to still stick with green, so if you still can't see it, let me know. Okay, which one is more complicated, left or right?
Right.
The right. Has more pieces, right?
Yeah.
Okay, so
Buttons are
what do you notice about the denominators?
opposite pairs.
Conjugate.
Conjugates. They're conjugate pairs, right? And I have fractions, and so fractions mean I have to have common denominators, correct? But if I multiplied
So 2
the left by 1 plus sign and the right by 1 minus sign, I'd have a conjugate pair, wouldn't I?
Yeah.
I mean, I'd have the 1 minus sign squared underneath.
Uh-huh.
Okay, so that's what we're going to do. So I just write one big fraction. Can you, Brad, is that still hard to see?
Not that what it was.
So you're telling me to get another pen?
No.
Yes?
You're doing the pen, I'm not gonna deny it, but.
Get a red one.
Yeah, red or purple usually works the best.
Oh my gosh, I'm using purple.
Okay, so 1 minus sign times 1 plus sign, they're conjugate pairs, so that's going to be 1 minus sine squared, correct?
Theta. Alpha.
Alpha.
You don't have to write it.
And if you want to write the alpha, that's fine. If you don't, to me, there's going to be a lot of alphas running around. It's just easier to do them at the beginning and at the end. Okay?
That's a
Now, that means I'm going to have to multiply the left fraction. 1 times 1 plus sign gives me what?
1
plus sign.
1 plus sign. Now I'm going to need to multiply the right fraction by 1 minus sign. And be careful, it does say plus, but if it was negative, you'd have to distribute the negative through, right? You have to remember, if you don't do the right math, like if you don't get common denominators, you don't distribute negatives, you're not going to come out with the right answer. You're going to be running in circles going, Mrs. Mick, this never works. Because you have to do the right math. Okay, so then I'm going to get what?
1 plus
Plus 1
Minus.
minus sign.
Would the sign, the 2 signs go together?
Well, I have a positive sign and a negative sign, so I have how many signs?
0.
0 signs. So I just have 1 plus 1 is 2. So I have 2 over 1 minus sine squared. And I will always tell you to keep your eye on the prize.
Wait.
Just a second. I'm talking. Keep your eyes on your prize. This is what I have. This is what I want. Do you already see what a part of what I want and what I have?
2.
The 2. So don't mess with the 2. Right?
Yeah.
Okay. Now,
Mess with your 2, Mrs. Nick.
Gosh.
don't mess with the 2. All the time I get people, well, I changed it. Why would you change it? That's what you want. Okay. Then we're going to think backwards. Well, I want secant. Well, secant is 1 over what?
1 over cosine.
Cosine. So can I make this
Into cosine? Yeah.
into cosine?
You sure can due to the Pythagorean.
Due to the Pythagorean identities right here, if I made the Pythagorean identity look like this, so that means I would subtract sine over, it would equal what?
Cosine squared.
Cosine squared.
So
Now, a lot of times you get excited and you're like, ooh, I know the answer, and you just write the answer. You can't skip steps. You gotta go through the steps. Now, can I finish it?
Yes.
Yeah.
Yes.
And that
So it's
is
going to be 2 times,
2 times 1 over secant.
I don't know, it's just secant.
Just write it.
Okay.
Because 1 over cosine is secant. And so I write the left because I'm done. And if I'm stuck, I mean, you always have to remember to look at what you want, because if you don't, you could go off completely wrong and not even get there.
So don't fool me.
Just remember the Alamo, Mrs. Smith.
Yes, always. Because that's the answer to everything.
You forgot the Alamo? That's what they said not to do.
What's
Okay.
the Alamo?
Just remember it.
Now, the other thing, when I was helping people yesterday, I had several people go, oh, we did this and this problem, let's do it. That's exactly what you're supposed to be doing. If you see something similar, like if you ever see this happen again, whether it's sine or cosine or tangent, are you going to do the same thing?
Yes.
You're going to get common denominators and you're going to say, okay, can I go to here? You repeat the same things. Just because it's a different identity I throw at you doesn't mean I do different math. No.
Oh, man.
Sometimes it comes down to just do the math that's in front of you.
Okay, before you, because I'm looking at you.
Yes.
So you've got 2 over 1 minus sine squared. You just rearrange the Pythagorean identity.
To make, yep. Because 1 minus sine squared would equal cosine squared.
And then reciprocal identity.
Yep. Exactly. And it's good that you're saying this name. Just because I'm not making you name them, it doesn't mean you don't need to know them, right? Okay.
Right.
Because you can communicate with that. So now I have the quantity tangent squared, x plus 1, times the quantity cosine squared of x minus 1 equals negative tangent squared of x. Guys, if they don't have the same variable, you can't do the same things with them. So then we have to do doubles and halves and all that kind of fun stuff. And angle addition and...
I have a question.
Mm-hmm.
Will we ever have one that's like tangent of x or and tangent of theta?
Yes.
Like in the same
Not
way?
today. Not for a while. But yes. Because that would be angle. We could use angle addition or subtraction.
Oh, we could.
They're different identities. Don't worry about it. You're not there. So don't worry about it. Okay. Any ideas?
Well, both of those are Pythagorean identities.
Yes,
One way
Carol
or
is
another.
correct. The tangent one would be secant.
Okay, so the tangent one is secant squared.
Uh-huh.
You guys want to do that?
Yes.
Okay.
Secant squared, and the other one, can we do 2 of the same step twice in one?
Yeah.
Okay, so secant squared times,
Nope.
sine squared?
Nope.
No? Negative sine squared?
It would be negative sine squared because you would be subtracting
Sine.
then 1 over, so that means you have to subtract the
So,
sine over. So make sure you're doing it correctly. So it's negative sine squared.
Secant is 1 over cosine
Okay, secant.
squared.
So I have 1 over cosine squared times negative sine squared.
Look at that. So we have negative sine squared over cosine squared.
So I have negative sine squared over cosine squared, which is what?
Tangent squared.
which is negative tangent squared
Negative tangent squared
of x.
of x.
Good job, guys. Now, was anyone at the beginning leery of changing this tangent squared? Did you stop for a second and think about it? Because what is my answer? Tangent squared. So, make sure if you're changing something, you have a plan in changing it. Okay? So, not that you were wrong. I would have had people. Could we think of another way to do this problem?
Yeah, probably.
I want us to try to think of another way.
Isaiah does.
So, second step. If I said I don't want to change the tangent squared because I don't want to get rid of it,
No, you can still change the other one.
I could still change the other one. So I could still have tangent squared plus 1 times negative sine squared. And then what would you do with that?
Distribute.
You would distribute it. So you'd have tangent squared times, actually you'd have negative tangent squared sine squared
Yup.
minus sine squared.
And then you could write it.
You'd probably have to still change that tangent squared, wouldn't you? Okay,
Wait, what'd you do? Did you just
distribute.
okay?
Okay, and so then we'd still have to probably do, so this would be sine squared over cosine squared, so that'd be sine to the 4th
That would be too confusing.
over cosine squared minus sine squared. Now I probably have to get what?
Oh my gosh! Don't change the baby numbers.
Common denominator.
Common denominators. So the common denominator is going to be cosine, right?
Yeah. So.
So negative sine to the 4th minus sine squared times cosine squared. Okay, am I making this really complicated?
Yeah, whatever you're doing.
Yep.
It's
We're just following the math. We're just following the math that it's taking me. But now I'm at the point going, what is going on? So now I have a sine squared here and a sine squared here. Probably have to factor out a sine squared, don't I?
Yeah.
Okay. So if I factor out a negative sine squared, I would have sine squared plus cosine squared. Got really easy really quick, guys, hopefully. What does sine squared plus cosine squared equal?
sine squared 1.
1. So that gives me negative sine squared times 1 over cosine squared. Well, what is sine squared over cosine squared?
Negative tangent squared.
Negative tangent squared.
That's too many steps.
So look how much more page that took.
Yes, look how much more it took. But what I'm trying to tell you is there more than one way to do this?
Yes.
Yes. And if you get yourself into this one on the right, if you get yourself into this situation and come in, I'm going to help you finish it. And there's times that I'll help you and we're going and we're like, you did 10 steps and we're 8 steps in. I'm like, okay, can I help you with a better way? Okay. But I'm not going to do that until it gets real deep. Makes sense what I'm saying? Because I would hope once you did this right-hand side, you'd be like, wait a second, I distributed it and then I factored it back out. So was there something better I could have done?
Yes.
Yes. Makes sense what I'm trying to get to? Okay.
So don't do the left side.
What?
Well, don't do the right side.
Unless you want to.
Well, unless you want to. Whatever is like sticks out to you is the best way to do it. So if that's the only thing that would stick out you to do, then that's what you need to do. And that's a hard pill to swallow, but you only get better at these by doing them and doing them poorly to figure out how to do them more
I
efficiently.
feel like the right one was too complicated.
It was. But what I'm saying is sometimes that's where your brain takes you.
We were still stuck on the second part.
Okay, tangent
You just like destroyed it.
of x, cosecant of x. I I need to put my parentheses. Equals secant of x. I want you to try that one.
These are the ones I have trouble with.
You're fine. There you go. Do that.
See, I'm doing it and I feel like I'm doing it wrong.
And just keep working. It only should be like two steps. 2 steps and then your final.
There's only 2 steps.
Hopefully you're working on the left.
No, I think I'm doing both. It'll be okay.
I don't even know what I'm looking at. Like
Okay, on the left, what can I do with those things? They're not
So,
Pythagorean,
tangent-
correct?
Tangent would be sine over cosine.
Okay, these aren't squared, so I can't use Pythagorean unless I'm going to put square roots in there, and I'm not putting square roots in there. Okay, so what would tangent equal? Whatever what?
Sine over cosine.
Sine over cosine.
And then cosecant would be 1 over sine.
And what happens to
The
your
sines
sines?
cancel out.
They reduce out.
Reduce out, sorry.
So 1 over cosine, which is what?
Secant.
Secant. Sometimes just going to sines and cosines is going to be your best bet.
See, I thought once you like got to sine over cosine times 1 over sine, I thought you couldn't reduce the sines.
Why wouldn't you?
I don't know.
Okay.
Because whenever I tried to do that before, it wasn't right.
Well, if you do it correctly, you were trying to do it when it was a quantity, and that's not correct. Okay, so tangent of x plus cotangent of x equals secant of x cosecant of x. Now, look how I wrote my problem. Probably moved it over a little bit too much. I moved over my right-hand side when I was writing my problem. Why did I move that over? Which one's more complicated, if you want to say?
The left.
The left. Okay. I would rather turn an addition into a multiplication than a multiplication into an addition.
Yeah.
Okay, so what do you guys think? First thing.
Cosecant. Yeah. I'm thinking turn tangent into cotangent.
Anybody else want to second his move? Or anybody else got a different idea?
Or, no, sine over cosine.
Who wants to go sine over cosine or making tangent cotangent? Speak up.
No,
No?
I'm not speaking at this.
Kendra, what do you think?
I have no idea.
Wait,
Adelaide?
Yes. Wait, did he say to make?
So he gave 2 options. He said we could make tangent into 1 over cotangent, or we could change tangent and cotangent into sines and cosines.
Let's make them sines and cosines.
You guys okay?
Yeah.
both of them sine.
Yes.
It would be sine over cosine and then sine
So we have sine over cosine
plus cosine over sine.
plus cosine over sine. So we have fractions and what's addition, and what should you naturally do when you have addition of fractions?
Common denominators.
Common denominators.
So,
So the
cosine,
denominator is going to be what?
sine times cosine.
So I'm just writing them in the order I have. Cosine, sine.
Yeah.
Okay, guys, if you look at the big picture, what should I have in my denominators when I'm done?
1.
Cosecant and secant.
What's secant and cosecant? What's in the denominators of those?
Cosine and sine.
Cosine and sine, aren't they?
Yeah.
So how are we moving in the right direction?
Yeah.
Yes. Okay, so we multiplied this fraction by what?
The
So,
sine.
Sine. So sine times sine is.
Sine squared.
You should
Plus
start feeling
cosine.
excited here. What do I need to multiply the right by?
Cosine squared.
Cosine. So I get cosine squared. Why did I say that?
Because you
Because-
have it.
What is my numerator?
1.
1. Anytime I can change something to 1, should my life get easier?
yes.
Yes? Because the Pythagorean identity is sine squared plus cosine squared equals 1. Well, 1 over cosine is what?
Secant.
Secant. And 1 over sine is
Cosecant.
cosecant. So I am done. And guys, when I say exactly the same, I mean exactly the same. If you wrote one side, bless you, cosecant, secant, and the other one secant, cosecant, I would take off a half a point. You forget your little box, I'm taking off a whole point.
Is it okay if I move the triangle?
Yes.
Okay. That one looked complicated, but it was pretty easy.
Thank you.
At least I feel like it was.
Okay, remember yesterday we had to rationalize sometimes? Sometimes you need to rationalize. I'm going to start a new side. Actually, I'm going to start a new piece of paper because I think I might go over.
How much room do you think I need for this next one?
Well, you're going to need, I would start at the top of a column. I don't know, 3/4. I don't know. Okay. Well, it depends how big you write. Secant of x plus, where's my problem? Tangent of x equals cosine of x over 1 minus sine of x.
So, right away I see that the right side can be turned into, well, never mind, it's not squared.
It's not squared. Okay? So, anybody else get like, ooh, wait, 1 minus sine is cosine. Yeah, but it's not sine squared, is it?
No, it's not.
So, could I do something to make it?
You can square
Nope.
both.
Okay. This side does not exist. We are not solving. We are simplifying. So, we can't multiply both sides of the equation by something. Yes?
Is it cosine 1 over sine?
No.
Should I put them together?
How could I make the denominator 1 minus sine squared?
I don't know.
Multiply by its what?
Reciprocal?
Its conjugate.
Oh,
Could I multiply both the numerator and the denominator by the conjugate?
yeah.
Yes. So if you want to show yourself that, I would let you do this. I won't let you FOIL it out, but you could do 1 plus sine over 1 plus sine. That's legal because I'm really just multiplying by 1. And our goal is to get 1 minus sine squared, which I can change into what? What does 1 minus sine squared equal? Cosine squared, doesn't it? Okay. So then that leaves me in the numerator as cosine. I'm not going to distribute the numerator just in case. because that might not be a good idea. And the denominator is going to be 1 minus sine squared. Now, I distribute out the denominator because my whole purpose is to get 1 minus sine squared to make it cosine squared, right? So what's my next step here? What does your denominator equal?
Cosine squared.
So I have cosine times 1 plus sine over cosine squared. Now I'm going to stop you for a second and say, look over at the other one. What is in the denominator of both of the left-hand side?
Cosine.
Cosine, not cosine squared. Could we get it down to cosine right now? Could I reduce 1 cosine out of the denominator?
Yes.
Yes, because they're out of the quantity, correct? So I would get 1 plus sine over
Well, cosine.
cosine. Now, real quick, if I would have distributed this cosine through, would I have seen that happening?
No.
No. So don't always, on the second part of that, don't always multiply it out because it may not be what you want to do. Well, if I can put a fraction together, if I can put two fractions together that have common denominators, can I pull them apart?
Yeah.
How do I know I want to pull these apart?
Because if you do, you'll have the thing.
How many things do I have on the left?
2.
2. How many things do I have on the right? 1. So I need 2, correct?
Yeah.
Okay, so this would get pulled apart as 1 over cosine plus sine over cosine. And what is that?
That's secant plus tangent.
Is that what we need?
Sure is.
Wait. Since there's only 1 cosine, can it still be pulled apart into 2?
Yeah, because that's how it goes. Like if I have 1/4 plus 2/4,
Oh, yeah.
I have 3/4, yes?
Yeah.
It's the same math. It doesn't change. And don't forget your box. Now again, the reason why I did this is because I knew I'd be going a little bit further than half of my page and I didn't want to write so small you couldn't see. So on your assignment today, it's 3 through 8 and then 9 through 39 odd. If you get stuck on one, serious, fold your paper in half, start it. If you get stuck, move to another one. At some point, these should be clicking. Got it? I expect probably a lot of half-done problems. If you go on Calc Chat, because I gave you all odds, and you just write down what they write down, you're not going to learn anything. If you look at it and you're like, oh, I understand why they did that, are you learning from it?
Yes.
Yes. So don't just go copy it. Yeah, you get your 5 points, but it's not going to help you out on the test, is it? Okay, we are not rushing through this unit, this section. So please do your assignment for learning.